So all of you listen carefully here. The fourth unit is force due to magnetic fields. Okay. Uh, for A section students, I covered this topic also. So after 10 minutes, let me complete within 10 minutes this topic. Later we will start another one. And this is also important. You will get a question in mid examination. This is related to Lorentz force equation, derivation of Lorentz force equation, and problem on it. Problem. So for mid examination, derivation of Lorentz force equation and a problem on the Lorentz force equation. Okay. So the forces in magnetic fields. So forces in magnetic fields means if there is a magnetic field is present, magnetic field B is present, B flux lines are present. If there is a presence of charged particle Q is exist in the presence of magnetic field, so what will be the force on this charge? Okay, and on the magnetic field B, if there is a conductor, then what is the force on this conductor? And in the magnetic field there are two conductors. Okay, then what is the magnetic force between the two conductors? So these are the three forces which we are going to discuss in this class, right? Let me talk about one by one. First one is force on charged particle. Charged particle means charge q. Charge q. The charge may be plus q or minus q. So uh, let me take a white board. If there is a plus q is there, then there is a Vistundama. Am I audible to everyone?
Yes, sir.
So this is an electric field, Amma. Okay, and if there is a plus q, and due to this plus q, there is an electric field E. And if I place another q, let us say q1 and q2, and we know that there is a there existence of a force between the two charges due to this electric field. So according to Coulomb's law, what is that force? Can anybody tell me? What is the force between the two charges according to Coulomb's law? We have already studied about this Coulomb's law in the first unit. Tell me the force F12 force due to 1 on Q2. Please respond anyone. Coulomb's law, if there are two charges, what is the force?
Q1, Q2 by R square.
Q1, Q2 by R square, and the proportionality constant is divided by 4 pi epsilon naught. Okay. So later we wrote F12 by Q1, which is equal to Q by 4 pi epsilon into R square. What is the force per unit charge? That is electric field intensity. Okay. So what I am going to write is E equal to force by charge. That implies force equal to Q into E. So this is equation 1. What is this equation says? This equation says that if there is an electric field E, this is an electric field E, if you place Q, which is at rest or which is in moving, even though it is rest, there is a force. Even though it is moving, again there is a force. That force equal to Q into E. Okay, that means if you placed a charged particle, if you place a charged particle in the presence of electric field, there is a force. That force is known as a electric force Fe. Fe equal to Q into E. This is our known equation, equation 1. So even though the charge is at rest position or in moving position, in the presence of which field, Amma? Is it electric field or magnetic field? In the presence of
Electric field.
Electric field, there is a force. That force equal to Q into E. Okay, na? This is related to electric field. Now, come to the another point called if the same charge is placed in a magnetic field. Magnetic field B. Somebody is joining. If you take a magnetic field B, so let us imagine this is magnetic field B. Okay, this is magnetic field B and this is magnetic field B. In the presence of the magnetic field B, and if you place Q here, which is at rest, which is at rest means stationary position, which is not moving. So in the presence of magnetic field, if you place Q here or anywhere, okay, the force exerted on this resting charge is 0. Fm equal to 0. Fm means force on a charged particle Q in the presence of magnetic field, and the charge which is at rest. Fm equal to 0. Fm means force due to the magnetic field. If it is at Q is at stationary position, Q is at stationary or at rest, which is not moving, okay, then the force is 0. It doesn't have any force, okay. But if you take an electric field, if you place a stationary charge, then the force is exist. But in the magnetic field, is not like that. Okay, if the charge is at rest, the force equal to 0. But if the same charge is moving with a velocity v, okay, if the charge is moving in the magnetic field with a velocity v, this is known as a moving charge. This is known as a moving charge. If the moving charge is placed in the magnetic field B, then there exists a force. Appruntunama force. Then only the forces exist. If that charge is at rest, Fm means 0. Fm means force on stationary charge due to the magnetic field B is 0. If the same charge is moving with a velocity v, then the force is exert on the stationary, sorry, on the moving charge. Okay, that force equal to Fm, and this force is perpendicular to the plane containing B and V. Suppose if you take our regular coordinate system x, y, z, if this B and V both are placed, B and V are placed in xy plane, the force exerted on this Q is perpendicular to plane containing B and V. That means it is along z axis. The force along the z axis, as the force is vector and this is Q. Can you guess what is the formula for the force which is moving in the presence of the magnetic field? Fm equal to Q into E cross B, where Q is the magnitude of the moving charge with the velocity V, and B is the magnetic field, and Q is the magnitude of the charge. Fm is the what? Force due to force on a moving charge in the presence of magnetic field. So let us say this is equation number 2. What is the equation number 1? Fe equal to Q into E. Okay, Nama. Fe equal to Q into E. This is equation 1. Earlier we discussed. What is the Fe? Force on charge in electric field. In electric field. What is the Fm? Force on charge in the on a moving charge in the presence of magnetic field. Okay. Now, my question is, if Q is moving in the electric field E and magnetic field B. Okay, now both the fields, electric field is there and magnetic field is there. Then the Q is moving. Now can you guess how many forces exerted on the charge Q, which is moving in the presence of both the fields? The resultant force F equal to, can anybody guess? What is the resultant force on Q? Equal to
Fe
4.
plus Fm.
Yeah, very good. Force due to electric field plus force due to magnetic field. And what is the Fe here from equation 1? Q into E plus. What is the force due to magnetic field? Q into V cross B. So if we take Q as common, then E plus V cross B. Okay, that is F. This equation is known as, what is this equation? Lorentz force equation. Very, very important. You know, Lorentz force equation is Q into E plus V cross B. E cross B. So for mid examination, it is very, very important. Okay, derive the Lorentz force equation. Means you have to derive F equal to Q into E plus V cross B. This is equation number 3. Okay. So if anybody have any doubts, you can ask here while deriving this equation, because I gave this question for mid examination. If anybody have any doubts, you can ask the question. You can ask the doubts. Doubts ఏం లేవా? ఓకే, మీరు ఏం రెస్పాండ్ అవ్వకపోతే నేను డౌట్స్ లేవని అనుకుంటాను. So this is the first force, the force on a charged particle. Okay. Now we'll discuss about the second force, and the problem is important on this equation. Let me do that problem also. Note down this equation, Amma. Note down this equation. Lorentz force equation equal to Q into E plus V cross B. Okay. Yeah, this is in the textbook concept. Force on a charged particle. F equal to Q into E. This is equation 1. Okay, Nama. So F is Q into E is force due to electric field. Electric field on a charged particle which is moving or which is at rest. Okay. Next. Another one is see this diagram. State of the particle. If the charged particle Q is at stationary, then we have the force which is equal to Q into E. Then if the charge is at rest, do you have any force on the charge in the presence of magnetic field? Force into the, if it is at rest, the force is 0. So the combined force is Q into E. Okay, Nama. Now see, if this Q is moving, if it is present in the electric field, then the force equal to Q into E. Okay, na? And if the moving charge is present in the magnetic field, then what is the force here? Force equal to Q into V cross B. Okay, then the final force equal to Q into E plus V cross B. So this is Lorentz force equation. So in the problem, if they want to ask the force due to only electric field, then F equal to Q into E. ఇది calculate చేయాలమ్మా. If you want to calculate force due to magnetic field, you have to calculate Q equal to V cross B. If you want to calculate the force due to both the fields, you have to add the Fe and Fm. Okay, na? So these formulas you have to remember. This is known as Lorentz force equation. Now let me share the problem here. Let me share the problem so that you can 4.8 I think so. ప్రాబ్లం నోట్ చేసుకోండి అమ్మా, సార్ నోట్ చేసుకోండి. ఏ పాయింట్ చార్జ్ ఎందుకంటే ఇలాంటి ప్రాబ్లం నేను ఎగ్జామ్లో ఇచ్చాను, నోట్ చేసుకోండి. ఏ పాయింట్ చార్జ్ Q equal to minus 1.2 coulombs has a velocity V equal to 5ax plus 2ay minus 3az meter per second. Find the magnitude of the force exerted on the charge if E equal to minus 18ax plus 5ay minus 10az volt per meter, and magnetic field B question, B equal to minus 4ax plus 4ay plus 3az Tesla, and C, if it is present, the moving charge is present both the fields, electric field and magnetic field. You have to solve this problem. I will give 5 minutes of time. You have to solve and tell the answer. I think A section వాళ్ళకి ఆల్రెడీ చేయించాను ఇది. B సెక్షన్ వాళ్ళు ఒకసారి చేయండి అమ్మా, 5 minutes టైం ఇస్తాను. ఏ వాళ్ళు కూడా ప్రాక్టీస్కి మళ్ళీ ఒకసారి చేయండి అమ్మా. I gave this problem to, అంటే సేమ్ కాదు ఇలాంటి మోడల్ ఫర్ ద మిడ్ ఎగ్జామినేషన్. నోట్ చేసుకున్నారా? ప్లీజ్ రెస్పాండ్, ఎస్ ఆర్ నో.
Yes, sir.
సాల్వ్ చేయండి. ఫస్ట్ వన్, హౌ టు సాల్వ్ ద ఫస్ట్ వన్? ఇట్ ఈస్ present in which field అమ్మా? First one, what is the first problem? It is present in which field? Electric field or magnetic field?
Electric field.
Then what is the formula for this F? F equal to?
Q into E.
Very good. Q into E. Okay, that is the formula for force in the electric field. For the B bit, what is the problem? The charge is moving in which field?
Magnetic field.
Very good. Then what is the force formula? Fm equal to Q into
V cross B.
Very good. V cross B. So for third question, we have to add these two forces. Okay, both are present simultaneously. If both the fields are present, then F equal to Fe plus Fm. So first question is simple. Take Q equal to minus 1.2 magnitude into E. E is minus 18ax plus 5ay minus 10az. So 1.2 that multiply చేయండి. Then you will get Fe. Next. ఎఫ్ఎం క్యాలిక్యులేట్ చేయండి అమ్మ. ఎఫ్ఎం ఈక్వల్ టు QV into V cross B. So first calculate V cross B. Later we can multiply with the Q. So V cross B equal to, as this V and B are in which coordinate system? Cartesian. You have to calculate V cross B like A cross B. What is the formula for A cross B? AX, sorry, first row is AX. What is the second row, Amma? Yeah. What is the second row? Second row what? First row is AX, AY, AZ. What is the second row?
5 2 minus 3.
Okay. Components of V. 5, 2, minus 3. Tell me the B components.
Minus 4 4 3.
4, 3. Now let us calculate this. So 2 into 3, 6, minus of 4 into 3, 12. Minus 12. Minus minus will get plus into AX. Minus చెప్పండమ్మా AY. What is the AY component? 5 into 3, 15, minus 3 into 4, 12, into AY, plus 5 in, అంతేనా బాబు? 5 into 4, 20, 4 into 2, 8, minus of minus plus AZ, which is equal to 18AX minus ఎంత వస్తుందమ్మా? 3
Yes, sir.
by 28 AZ. So this is V cross B. Now calculate the total force Fm, which is Q into V cross B. What is the Q? Minus 1.2 into this value, 18AX minus 3 into AY plus 28AZ, which is equal to, multiply this one and tell me the answer. So this is Fm. So we calculated Fe and Fm. For the C question, add these two forces, then you'll get the final answer. Tell me the final answer, Amma. Final answer ento cheppandi. So everyone has to practice this problem. I gave this problem in the examination. ఇక్కడ వరకు ఏ వాళ్ళకి చెప్పానమ్మా. నెక్స్ట్ కంబైన్డ్గా నెక్స్ట్ స్టార్ట్ చేస్తున్నా. ఆన్సర్ చెప్పాలమ్మా. ఐఎమ్ ఎక్స్పెక్టింగ్ ది ఆన్సర్, ఫైనల్ ఆన్సర్. What is the answer? Final answer. What is the final answer?
Minus 2.4 AY minus 21.6 AZ.
Minus
4 AY
2.4 AY.
minus 21.6 AZ.
Okay. So what are the units? What are the units for force? Newtons. Okay. So this is about the force on a charged particle. Now, next one. Force on a differential element. బాబు అర్థమవుతుందమ్మా ఎనీ డౌట్స్ ఉన్నా యూ కెన్ ఆస్క్ ద డౌట్స్ ఫోర్స్ అనే డిఫరెన్షియల్ ఎలిమెంట్ ఓకే డిఫరెన్షియల్ కరెంట్ ఎలిమెంట్ డిఫరెన్షియల్ current element. Suppose if I take a conductor like this is the conductor. For this conductor, if I apply voltage in a certain place, then current is, please respond. Current is flowing in this conductor. I is flowing in this conductor. I is flowing means, and let us say the length of the conductor is L. If I is flowing means what is the current? Flow of electrons. Current is flow of electrons. That means flow of charges. Electrons means charges. Flow of charges. So charges are moving inside the conductor. Okay, now the charges are moving inside the conductor. Out of total length L, Rakesh వినిపిస్తుందా బాబు?
Yes, sir.
Out of total length L, I am taking differential length dl. నేను differential length dl తీసుకుంటున్నాను. Small length in the conductor. I take differential length dl. Okay. Then what can I say? Ideal. What is this ideal? Ideal is differential current element. Differential current element. Ideal. Okay, now so in the differential length there are charges called dq. Okay, and these are flowing with respect to time. Okay, then dq by dt. So what is the dq by dt? Time rate of flow of charges is what? I. What is the I amount? I is equation అర్థమైందా?
Yes, sir.
బేసిక్ ఈక్వేషన్ కదా. I equal to dq by dt. What is the dq? Differential charge in the length of dl. Okay. Now in this ideal, what I am doing is that instead of I am writing dq by dt into dl. Okay. Now I am writing this dt below the dl, then dl by dt. అర్థమవుతుందమ్మా?
Yes, sir.
Now this dl is what? Differential length or displacement. So displacement by time. What can we write in place of dl by dt? Distance by time. What is the distance by time?
Velocity.
Very good. That is velocity. So velocity is it a vector or scalar, Amma? Velocity is a
Vector.
vector. So I am writing dq into v. Okay, na? So ideal equal to what can I write? dq into v, where v equal to dl by dt. Okay, na? Now come to the point here. It is placed in magnetic field B. This conductor. Conductor is placed in magnetic field B. Okay, now the conductor is present in the magnetic field B. As per previous discussion, if the moving charges are present in the magnetic field, okay, which is present in the conductor, there exists a force on this conductor. The force is exerted on the moving charge. Due to the force on the moving charge, the force is applied or the force is exerted on this conductor. Now, what is that force? That force is known as magnetic force. What is the force in the magnetic force on the differential conductor in the magnetic field? Or what is the actual formula?
Q into V cross B.
Q into V cross B. But here we took Q or dq. ఇప్పుడు మనం ఏం తీసుకున్నామా? dq తీసుకున్నాం. డిఫరెన్షియల్ లెంత్ లో డిఫరెన్షియల్ ఛార్జ్ ఉంది. ఓకే, ఫర్ దట్ I have to write dq. If I take dq, is it a total force or a differential force?
Differential force.
Very good. So dfm equal to dq into v cross b. Okay, this is due to force in the magnetic field on differential current element. Okay, now let us say previously, let us say this is equation 1 number. What is the equation 1? I into dl equal to dq into v. Okay, now see this dq into v. See this dq into v. Let us say this is equation 2 and this is equation 1. From 1 and 2, can I replace this dq into v by ideal cross b? Instead of writing dq into v, what I have written? Ideal. So ideal cross b, that is dfm. Okay, now if I want to get, this is differential force. If I want to get total force, how can I calculate here? Total force Fm equal to integral ideal cross b. Okay, ideal cross b. If you take the same formula, then the force on this total conductor, which is having the length L, then also you can write Fm equal to I into L cross B. మీరు వినే ఉంటారు ఈక్వేషన్ magnetic force. So there is a conductor like this and which carries a current I here and which is having the length L and it is placed in the magnetic field B. Okay, then the force F equal to I into చెప్తారా L cross B. ఓకేనా I into L cross B or I into, can you expand this, B into L into sin theta. Okay, then the direction of the force is in the direction of AN. This is the force. You might have studied about this equation earlier in electrical machines. The force in the motors is BIL sin theta AN. So this is the force. Force equal to BIL sin theta AN. So this is, and AN is the unit vector. Unit vector in the direction of force. Okay, now how to find the force? Now there is a magnetic field B and the current I is flowing in this direction and the force exerted on this conductor according to Lorentz force equation. Now how to find the direction of the force? Now direction of force can be find by using which law amma? Which rule? మీరు మిషన్ చదివారు కదా. The direction of the force can be found by using force ఎలా ఫైండ్ అవుట్ చేస్తారు? By using the which rule? రాకేష్ మోటార్ చదివారు కదమ్మా. What is the name of the rule?
Left hand rule.
Means good. Means left hand rule. What is that rule? What the rule says? If you stretch your left hand fingers like this, where this is forefinger shows the field and center finger shows the current. Field I'm not sure. This is field B, current I. This is forefinger, this is center finger and this is forefinger and the direction of the force is in upward direction, that is F. Okay, now if you apply the left hand rule for this conductor, can you tell me the momentum of or the direction of the force which is exerted on this conductor? Is it upward or downward?
Upward.
Very good. It is upward direction because in this direction you have placed which finger, amma? Center finger. In this direction you have to place which finger? Forefinger. Then compulsory our thumb will be perpendicular to both. Please respond. Perpendicular to center finger and forefinger. This is force. Okay, so this is the force on differential current element. Okay, so you might have used this formula, magnitude of that force equal to BIL sin theta. What is the theta? Theta is the angle between conductor and conductor and magnetic field. Theta is the angle between this conductor and this magnetic field. Note చేసుకునేది very very important. మీరు మిషన్స్ లో ఇదే చదువుతారు. In this case, this AN is in the direction of the force. నోట్ చేసుకున్నారమ్మా? ఇంతకుముందు షేర్ చేయనా? ఇది షేర్ చేస్తాను. ఇది నోట్ చేసుకోండి. ఫోర్స్ ఆన్ డిఫరెన్షియల్ కరెంట్ ఎలిమెంట్. ఒక 2 minutes టైం ఇస్తాను, నోట్ చేసుకోండి. ఇది బాబు రాకేష్ ఫాలో అవుతున్నావా బాబు?
Yes, sir.
What about the remaining students? Srinivas, 38. Srinivas, ఉన్నావా బాబు? నోట్ చేసుకున్నామా? నోట్ చేసుకోండి. ఇక్కడ ఐడియల్ ప్లేస్లో ఎలా రాసామో క్లియర్గా ఉంటుంది. ఈ డయాగ్రామ్ నోట్ చేసుకోండి, ఈ ఈక్వేషన్స్ నోట్ చేసుకోండి, ఫైనల్గా ఈ ఈక్వేషన్ కూడా నోట్ చేసుకోండి. ఎందుకంటే ఇవి టెక్స్ట్ బుక్లో ఉండవు. సో ఒక 2 minutes టైం ఇస్తాను, మీరు నోట్ చేసుకోండి. మనం నోట్ చేసుకున్న తర్వాత కంప్లీట్ అయిపోయిందని చెప్పండి. నెక్స్ట్ స్లైడ్ షేర్ చేస్తాను. నోట్ చేసుకున్నారా అమ్మా?
Yes, sir.
నెక్స్ట్ స్లైడ్ షేర్ చేస్తాను. So this is the second force. This is the second force. First force is force on a charged particle in the presence of magnetic field and electric field. Second force is force on a differential current element. Force on a differential current element, which is equal to F into I into L cross B. I into L cross B formula. Two more forces are there. After discussing two more forces, okay, we will finish the forces in a magnetic field. Later, we will discuss about magnetic dipole and torque in a magnetic dipole. This chapter is very much useful to understand the electrical machines concepts. Without having these basics, you cannot understand the electrical machines basics. Force ఎలా వస్తుంది? Motor. What is the motor? Which converts electrical energy into mechanical energy. Okay. So how this motor converts electrical to mechanical? It is explained by the Lorentz force equation. After completion of this chapter, we can clearly understand that motor working principle. Okay, now third force. Before discussing about the third force, let me do a small problem on it. This one is not the problem. See, note down this problem. A conductor. Rakesh, are you able to see this problem? Example 8.2.
Yes.
Yeah, note down this problem. A conductor 6 meters long. A conductor 6 meters long lies along Z direction with a current of 2 amperes in AZ direction. Z direction lies along Z axis with a current of 2 amperes in AZ direction. Okay. Find the force experienced by the conductor if B equal to 0.08 AX Tesla. Note చేసుకున్నాము. Now, yeah, what is the force equation for this problem? F equal to please anyone can respond. F equal to
BIL sin theta.
Babu.
BIL sin theta.
DIL sin theta.
Before that, as these are given in vectors, so in the direction of AZ, and this length is also given in the direction of AZ, you have to write I into L cross B. ఓకేనమ్మా, వెక్టర్స్లో ఇచ్చారనుకోండి ఈ ఈక్వేషన్ యూజ్ చేయాలి. అదే వెక్టర్స్లో ఇవ్వలేదనుకుంటే దెన్ యూ విల్ గో ఫర్ ఇంటిగ్రల్ I into L cross dl cross B, or else only the B is given, magnitude of the B is given, and only the length is given, and only the current is given. If the vectors are given, you have to write F equal to I into L cross B. If you expand this, you will get BIL sin theta. Okay, they will give only magnitude and angle also, then you will use BL sin theta. But if they give in the form of vectors, then you use F equal to I into L cross B. Okay, now how to find it? What is the I? F equal to I is how many amperes?
2 amperes.
2 amperes. What is this L? Vector.
Six
L is a vector. 6 m, as it is in meter, no need to convert. M 6 into the current is flowing which direction? I mean the length dl is differential length. Length is you have to take in the direction of az. So 6 into az cross b. What is the b? This is the b, 0.08 az. Okay na? Then which is equal to 2 into రెండింటి క్రాస్ ప్రొడక్ట్ చేయాలమ్మా. 6 into 0.08 into AZ cross AX. What is the AZ cross AX?
AY, sir.
AY. Okay, then the total value equal to 2 into 6 into 0.08 AY. Now చేసుకోండి, సింపుల్ ప్రాబ్లం. Okay, next third force. Force between two current loops. Third force is force between two current loops. So listen carefully here. So this is loop 1. Loop 1 means this is the conductor as a loop, and here the voltage is applied. This is plus and minus, so the current is flowing in this direction. Next, another loop is there. This is also a conductor, and here the current is flowing in this direction. So current is flowing in upward direction. Now listen carefully here. If the current is flowing and in this fashion, when the current is flowing in the conductor through this conductor, loop means this is conductor, current is flowing, then around this conductor you have చెప్పండమ్మా
Magnetic
ఏముంటుందమ్మా
field.
వెరీ గుడ్ మ్యాగ్నెటిక్ ఫీల్డ్ ఉంటుంది ఓకేనా so this is the magnetic field and this magnetic field is what you call exists up to this conductor. Let me take another color. Magnetic field ఇక్కడ ఉంది. So this is magnetic field B అనుకోండి, otherwise B1 అనుకోండి. Next, this is conductor. Okay, if this conductor is placed in the magnetic field, what is happening as per latest discussion? If this conductor is placed in the magnetic field, there exists a, please respond, force on the conductor. Similarly, let me take in different way. Now, let us see this. Now I2 current is flowing. So in this, when this I2 current is flowing, according to the Eirsted experiments, around this conductor also there is a which field? Magnetic field B2. As this I2 current is flowing, let us say this is B2. In the magnetic field B, there is a conductor. This is the conductor which is placed in the magnetic field. Here also there is a force on చెప్పండమ్మా which conductor? This conductor. Force on this conductor. Okay, now how many forces are here? Two forces. We have to calculate those two forces. First force is force due to which magnetic field? This
B1.
magnetic field B1. Okay, na? But here what I am doing is that here out of total length L, here I am taking a differential length. ఇక్కడ కొంచెం differential length dl1 గా తీసుకుంటున్నాను. ఓకేనా? So due to this differential length dl1, the magnetic field is db1 అంటాను. Here we have to select a differential length so that the magnetic field is db1. So force due to db1. db1 means జాగ్రత్తగా నమ్మ కొంచెం కన్ఫ్యూజింగ్గా ఉంటుంది. magnetic field or differential magnetic field due to loop 1. So loop 1 వల్ల వచ్చే differential magnetic field db1. What it is doing? So this differential magnetic field in that differential magnetic field db1, this conductor is present. Okay, here also we took not total length L2, this loop length is L2, so that here I have taken small differential length dl2. dl2 తీసుకున్నాను. Okay, so force due to db1 means differential magnetic field due to loop 1 on which conductor? Differential length of conductor. జస్ట్ వినండి, తర్వాత మీరు దీనికి రిలేటెడ్ నోట్స్ పంపిస్తాను, అప్పుడు చదువుకోండి. ఎందుకంటే మీరు చెప్పి రాసుకోవడానికి అంత టైం ఉండదు. కావాలంటే ఇది నేను రికార్డ్ చేస్తున్నాను, అది మీకు షేర్ చేస్తాను, తర్వాత మీకు రెఫరెన్స్ ఉంటుంది. ఆ వీడియో చూసుకుంటూ నోట్ చేసుకోండి.
సార్ యూట్యూబ్లో అప్లోడ్ చేస్తారా సార్?
ఇవన్నీ యూట్యూబ్లో ఉన్నాయమ్మా, చూసుకోలేదు. మీకు లింక్స్ కూడా పంపించాను రా బాబు. ఇది యూట్యూబ్లో అప్లోడ్ చేస్తాను. ఆల్రెడీ మీ కొన్ని క్లాసెస్, మీ సీనియర్స్కి చెప్పిన క్లాసెస్ ఆల్రెడీ నేను లింక్ పంపించాను. ఆ లింక్లో కూడా మీరు చూడొచ్చు. అది మీకు అర్థమవుతుందో లేదో అని మీకు ఒకసారి రివైజ్ చేస్తున్నాను. ఎంతమంది చూసారా అసలుకి ఆ లెక్చర్స్? లింక్స్ పంపించారా మీకు సిఆర్స్?
మాకేం పంపలేదు సార్.
గ్రూప్లో లేరా మీరు?
ఉన్నాం సార్.
మరి గ్రూప్లో వస్తాయి కదా, పర్సనల్ గ్రూప్లో పంపించమని చెప్పాను. పర్సనల్ గ్రూప్లో లేరా మీరు?
ఉన్నాం సార్.
మరి ఉంటే రావాలి కదా. సెక్షన్ ఎవరో మీ సెక్షన్ ఏంటి? బి సెక్షనా?
యా సార్, బి సెక్షన్.
గణానందకి
పంపించాను రా బాబు. గణానంద్ ఏ సెక్షన్ కదా?
ఏమో సార్.
ఏ సెక్షన్ వాళ్ళకి వచ్చాయమ్మా? బి సెక్షన్ బాలానా ఆమె పేరు సిఆర్ పంపించాను
సార్. వచ్చాయి సార్.
బి వాళ్ళకి కూడా వచ్చిందా?
వచ్చాయి సార్.
అతను ఒకసారి గ్రూప్లో యాడ్ చేయండి అయ్యా గణేష్ని. గణేష్కి పర్సనల్గా ఏమైనా పంపించండి. గణేష్
నాకు పంపండి సార్.
మీ నెంబర్ నాకు ఒకసారి మెసేజ్ చేయండి, మీకు మళ్ళీ పంపిస్తాను.
ఓకే సార్.
సో ఇది కూడా ఉంది మీకు యూట్యూబ్లో, ఇది కూడా పెట్టాను. నౌ ద ఫోర్స్ ఆన్ డిఫరెన్షియల్ లెంత్ ఆఫ్ కండక్టర్ డిఎల్, విచ్ కండక్టర్ అమ్మా? డిఎల్2 ఆర్ డిఎల్1? డిఎల్2, ఓకేనా? ఈజ్ గివెన్ బై, అర్థమవుతుందా బాబు?
ఎస్ సార్.
What we are calculating here, magnetic field is due to this current loop, which is dB1. Okay, and in this magnetic field, this dl1 is present. So magnetic field undi and conductor undi, and ee conductor lo malli current flow avutundi, I2 current flow avutundi. What is the Lorentz force law? Whenever current carrying conductor placed in a magnetic field, it experiences a force. Okay na? Now let me write that force formula. That force is dF1 2. What is the d of dF1 2? చెప్తారా? ఫోర్స్ డ్యూ టు, చెప్పండి. ఫోర్స్ డ్యూ టు డిఫరెన్షియల్ మ్యాగ్నెటిక్ ఫీల్డ్. ఫోర్స్ డ్యూ టు డిఫరెన్షియల్ మ్యాగ్నెటిక్ ఫీల్డ్ dB1 or dB2 అన్నా?
dB1.
Very good. Force due to differential magnetic field dB1 on which conductor? Differential current element DL1 or DL2?
DL2.
Which is carrying a differential current element I2 into DL2. You have to write I2 into DL2 is the what? D of dF12. D of dF12 equal to, what is the formula here? What is the formula? Previously we derived, right? Force equal to I into L cross B. You have to take this as reference. What is this I here? What is this I? What is the current? Current is I2. What is this L2? What is this L2 Amma? DL2 cross. What is the magnetic field? 1. Are you getting me or not? I have taken this equation as reference and I wrote this formula. If anybody have any doubts in this, you can ask. Rakesh, equation clear na? Doubts
Yes, sir.
Okay, na? So what is this equation? Differential force due to differential magnetic field dV1 on differential current element I2 dL2. So from this equation, I wrote this formula. So let us say this is equation 1. Now I have to calculate dB1. So what is the dB1 from Biot-Savart's law? We have dH actually. dH equal to I into dl cross
Sin alpha.
సైన్ లో కాదు క్రాస్ లో చెప్పండి I dl cross AR కదా AR by
R square.
R square 4 pi ఉంటుంది కదా I dl cross AR by 4 pi R square. If I want to get dB, what is the relation between B and H? B equal to mu into H. So dB equal to mu into dH, which is equal to I into dl. Now dB1 I am calculating. Okay, so I have to take the loop as first loop 1, which carries the current I1, and this is dl1, and this is I into dl2, and this is loop 2, and current I is flowing in this direction. And what is the R? Distance between this loop and this loop. Okay, so now I have to take this distance from here to here. This is R12. Okay, R12. This is loop 1 and this is loop 2. This is loop 2. R12. So which one I have to write? I dl1 or 2? dl1 or dl2? This magnetic field is related to which loop?
First loop.
First loop. So what should I write? dl1 cross AR means unit vector along AR12. So AR12 divided by 4 pi into R12 magnitude whole square. Okay, na? Now let us substitute. This is equation 2. Substitute equation 2 in 1 in this dB1. ఫాలో అవుతున్నారమ్మా?
Yes, sir.
కొంచెం కన్ఫ్యూజింగ్గా ఉంటుంది. Try to understand. Now if I substitute this, what I will get? D of dF12, which is equal to I2 dL2 cross, in place of dB1 I am substituting mu into I1 dL1 cross AR12 divided by 4 pi into R12 magnitude whole square. Okay, which is equal to I am writing this currents and permeability separately. I1, I2 by 4 pi. Okay, na? And df2 means how many integrals are there? If I do integration, how many times I have to do integration to get f1 to?
Two
Two
times.
times.
F12 equal to mu into I1 I2 by 4 pi. As these are closed loops, closed loop L1 and closed loop L2, dl2 cross dl1 cross R12 divided by R12 whole square. This is, what are the units for this force? Newtons. This is the what? Total force. F12 is the total force on which one? Current loop 2. Current loop 2 due to magnetic field produced by which loop?
One, sir.
Loop 1. Okay, na? So this is equation 3. Likewise, we'll be having another force. What is that force? F21. What is the F21? Total force on which loop?
First loop.
First loop due to magnetic field produced by
Loop 2.
loop 2. Okay, that is F21. Similarly, you have to write the equations, and I am giving direct formula. That formula is, do practice as a homework. Mu into I1 I2 divided by 4 pi integral loop L1 integral loop L2 dl1 cross dl2 cross చెప్తారా ఎవరన్నా? AR
2, 1.
very good. AR21 divided by R21 magnitude whole square. This is equation 4. So these are the two forces between the two current loops. But here you have to do triple integral here, dl2 cross dl1 cross AR2. Okay, so this is another force. So far we have discussed 3 forces. First force is force on charged particle, means moving charge in electric field and magnetic field. Next, force on differential current element. Now let me write this force. F equal to Q into E plus V cross B. Force on differential current element, that F equal to integral I dl cross B. So it can be also written as, this differentiation integration sometimes may cancel out, L cross B. This is the force on differential current element. Third one is force between two current loops. Here we have two forces. One is F12 force due to loop 2 on loop 1, which is equal to mu into I1 I2 by 4 pi closed line integral L1 L2 dl2 cross dl1 cross AR12 divided by R12 whole square. Likewise, F21 also. Okay, now these are the three forces so far we have discussed. Now let us discuss last force. ఇంతవరకు క్లియర్గా ఉందమ్మా? ఇవన్నీ అర్థమైతే మీకు లాస్ట్ ఫోర్స్ ఉంటుంది, అర్థమవుతుంది. మీకు ఏమైనా డౌట్స్ ఉంటే అడగచ్చు ఇప్పుడే. డౌట్స్ ఏం లేవా? తరుణ్, గణేష్, 228.
No, sir.
Okay. Next. Snigdha, LE12.
సార్
డౌట్స్ ఏమి ఉన్నాయమ్మా?
లేవు సార్.
ఓకే, గుడ్. మనీష్, ఉదయశ్రీ,
No, sir.
ఫాలో అవుతున్నావమ్మా?
Yes, sir.
Okay, good. So these are the three forces. Now, last force is force between two conductors. ఇవన్నీ ఇప్పుడు ఎందుకు నేర్చుకున్నామంటే ఫైనల్గా మనకి ఫోర్స్ బిట్వీన్ టూ ప్యారలల్ కండక్టర్స్. ఇది ప్రాక్టికల్ సిచ్యువేషన్ అమ్మ. ఫోర్స్ బిట్వీన్ టూ ప్యారలల్ కండక్టర్స్. వేర్ కెన్ యూ సీ టూ ప్యారలల్ కండక్టర్స్? ఎక్కడెక్కడ చూడవచ్చు? కెన్ యూ గెస్?
Capacitors.
అవి ప్లేట్స్ అంటే ఐ మీన్ అది కూడా తీసుకోవచ్చు. బట్ ఇక్కడ మ్యాగ్నెటిక్ ఫోర్స్, అది ఇక్కడ అక్కడ ఎలక్ట్రిక్ ఫోర్స్ ఉంటుంది బాబు. ఇదే ఫోర్స్ మ్యాగ్నెటిక్ ఫోర్స్. ఇఫ్ యూ టేక్ మోటార్ కాన్సెప్ట్, మోటార్లో పార్ట్స్ చెప్తారు నాకు. వన్ ఈజ్ స్టేటర్, అనదర్ వన్ ఈజ్ రోటర్. రోటర్కి ఇంకో పేరేంటమ్మా? ఆర్మేచర్. సో ఇఫ్ యూ టేక్ ఆర్మేచర్, సో దిస్ ఈజ్ ఆర్మేచర్ విచ్ ఈస్ హ్యావింగ్ స్లాట్స్. ఇలా ఉంటాయి కదా స్లాట్స్. ఇన్ ద స్లాట్స్ వీ హ్యావ్, ఇంతేనా బాబు స్లాట్స్ ఉండేది? ఇన్ ది స్లాట్స్, on armature slots, what we are placing here?
ఆర్మేచర్ కండక్టర్స్.
Armature conductors. So this is one conductor and this is another. We know armature winding. After doing armature winding, so this is one conductor and this is another conductor. మనకి మోటార్లో రోటర్కి ఏమి ఇస్తామమ్మా? సప్లై ఇస్తాం కదా. వాట్ ఈస్ ద మోటార్ వర్కింగ్ ప్రిన్సిపల్ విచ్ కన్వర్ట్స్
ఎలక్ట్రికల్
electrical to mechanical kada. So based on Lorentz force equation, what is the Lorentz force equation? Whenever, don't confuse between Faraday's law and Lorentz force equation. Whenever
current carrying conductor placed in magnetic field, it experiences force.
placed in magnetic field, it experience a force kada. ఫోర్స్ వస్తుంది, తర్వాత టార్క్ వస్తుంది. సో యాజ్ యూ హ్యావ్ టు గివ్, టు ప్రొవైడ్ కరెంట్ క్యారింగ్ కండక్టర్, యూ హ్యావ్ టు గివ్ ఎన్ ఎలక్ట్రికల్ సప్లై. సో ఈ కండక్టర్స్కి మనం ఎక్స్టర్నల్ నుంచి ఏమి ఇస్తామమ్మా? సప్లై ఇస్తాం. సో దట్ దీస్ ఆర్ క్యారింగ్ ది కరెంట్స్. అర్థమవుతుందా? సో ప్యారలల్, టూ ప్యారలల్ కండక్టర్స్ మీన్స్ the conductors which are placed in the slots of armature. That is one example. Another example is transmission lines. Transmission lines kuda conductor flow avutundi. Next, another one is if you take transformer winding, primary winding ఉంటుంది కదా, primary winding లో ఇదొక కండక్టర్, ఇది ఇంకో కండక్టర్. So these are conductors. When the current is flowing through this conductor also, there is a force. These are some examples of parallel conductors. Okay. Now, how this rotor is going to be rotate? So electrical energy ఇచ్చినప్పుడు rotor rotate అవుతుంది అంటారు కదా, మెకానికల్ ఎనర్జీ ఎలా కన్వర్ట్ అవుతుంది అండ్ దాని యొక్క మ్యాగ్నిట్యూడ్ ఎంత. సో దోస్ థింగ్స్ వీఆర్ గోయింగ్ టు డిస్కస్ ఇన్ దిస్ మ్యాగ్నెటిక్ ఫోర్స్ బిట్వీన్ టూ ప్యారలల్ కండక్టర్స్. ఓకేనా? సో let us discuss it. For this, let me share this one. Actually, this is a problem. Two long wires anna conductor anna both are same. First, vinandamma. Two long wires are conductors carrying current I1 and I2 in the same direction along positive z direction and located in free space. Okay. Now find the force per unit length on a wire 2 due to wire 1, force per unit length on wire 1 due to wire 2. Also state whether the force is attractive or repulsive. Okay. So this is the problem, and related to this problem I am going to share with screenshot తీసుకున్నామా తర్వాత మీకు I am going to share a diagram for the problem. See this. Here we are taking the coordinate system differently. This is our regular axis. This is our x-axis. And this is y-axis. Generally, మనం ఎలా తీసుకుంటాం మా ప్రీవియస్ కేసులో ఇది x, y, z లాగా తీసుకుంటాం కదా. As the conductor is placed along the z-axis, for our convenience, here we are taking this as z-axis, this as x, and this as y. That is our wish. ఇక్కడ ఇచ్చిన ప్రాబ్లం ఎలా ఉంది అందుకని ఇలా తీసుకుంటున్నాం. సో దిస్ ఈజ్ z-axis. ఓకేనా? Now where the conductor is placed, where the two conductors are placed, the conductors are placed along
Z-axis.
z-axis. As we have taken in this direction, this is one conductor and this is another conductor. ఇది ఇంకొక కండక్టర్. ఇది చాలా జాగ్రత్తగా వినండి అమ్మా. ఎక్స్టర్నల్ ఎగ్జామ్లో కానీ వెరీ వెరీ ఇంపార్టెంట్. derive the force equation between the two parallel conductors. Current is flowing in same direction, లేకపోతే ఆపోజిట్ డైరెక్షన్ కూడా ఇచ్చే ఛాన్సెస్ ఉంటుంది. కంపల్సరీ క్వశ్చన్, ప్రాబ్లం కానీ క్వశ్చన్. సో దీస్ టూ బ్లూ లైన్స్ ఆర్ ద conductors. Now, how the current is flowing? Current is flowing in positive z direction. Positive z అంటే ఇది పాజిటివ్ z యాక్సిస్. కరెంట్ ఇలా ఫ్లో అవుతుంది, and this current is I1 and this current is I2, and these two conductors are having the length. So this conductor 1 length is L1 and this conductor length is L2. This is L2, and the distance between the two conductors is D. These two conductors are separated by a distance D. Okay, now Again, I am repeating. These are the two parallel conductors which are placed along the z-axis in the positive z direction. Current I1 and I2 are the currents which are flowing in the same direction. Current is sometimes they will give an opposite direction. I1 is flowing in this direction, I2 E direction is there. Then also you have to calculate the forces. Okay. First I am going to derive the expression for the current in the same direction. Later you have to do as a homework. The current is flowing in opposite direction. Okay. Now, so this is the distance d. Now, when the current is flowing through this conductor, according to Oersted experiments, around this conductor there is a magnetic field V1. So this magnetic field will be like this, and this conductor 2, this is conductor 2. This conductor 2 is placed, and current carrying conductor. Current carrying conductor I2 is placed in the magnetic field B1. According to Lorentz force law, what will produce in this conductor 2? Force will be exerted on conductor 2 due to magnetic field B1. Then that force is written as F12. The notation is important. F12. What is this F12? Force on conductor 2 due to magnetic field B1. Rakesh Babu, follow the normal.
Yes, sir.
Okay. F12 is the force on conductor 2 due to conductor 1. Okay, na? What is that formula? So magnetic field B1 means you have to write B1 cross current I2 into L2. What is our force equation? F equal to I into L cross B. F12 means F12 means force due to conductor 1. 1 ఉంది కదా, 1 అంటే due to. Force due to conductor 1 means magnetic field B1. Okay na? On conductor 2, which carries the current I2 and which is having length L2. Okay, so that is called F12. Okay na? So let me write that one separately here. Let F12 be the force on conductor 2 due to conductor 1. F12 equal to I2 L2 cross B1. Okay, I2 L2 cross B1. So let us say this is equation 1. Next, similarly here you have to calculate B1. What is the B1 here? B1 equal to again mu into H1. What is the H1? H1 is magnetic field intensity due to conductor 1 at a distance of d is given by చెప్తారా ఎవరన్నా మనం ఆల్రెడీ డిస్కస్ చేశాం కదా ఫస్ట్ ఇదే డిస్కస్ చేశాం if there is a conductor for this let me give some review of the previous class then only you can understand. Before that let me share here, share this. See here. So this is current I1. Current is flowing in this direction, I1. I am calculating the magnetic field intensity at this point. ఇక్కడ నేను H1 క్యాలిక్యులేట్ చేస్తున్నాను, ఈ కండక్టర్ దగ్గర H1 క్యాలిక్యులేట్ చేస్తున్నాను. అకార్డింగ్ టు ద ఫార్ములా H1 ఈక్వల్ టు చెప్తారా వాట్ ఈస్ ద H1 డ్యూ టు ద స్ట్రైట్ కండక్టర్. H1 due to straight conductor. Let us say it is an infinite long conductor అంటాడు. Long means approximately you can take H1 equal to మీకు థర్డ్ యూనిట్లో ఫస్ట్ చెప్పాను కదా I1 by 2 rho చెప్పాను కదమ్మా 2 rho AL cross AR గుర్తుందా లేదా? యాక్చువల్ ఇట్ ఈస్ A5 ఎలా రాసామంటే AL క్రాస్ AR రాసాను. వాట్ ఈస్ ద AL? AL is the unit vector in the direction of current. What is the AR? AR is the unit vector in the direction of field point. గుర్తులేదా బాబు? థర్డ్ యూనిట్ స్టార్టింగ్లో చెప్పానమ్మా మీకు. అదర్వైజ్ లెట్ మీ ఇది అర్థమైతేనే మీకు వస్తుందమ్మా. లెట్ us take the current I1 at this field point at a distance of d. I want to calculate H. Then formula for H equal to I1 by 2 pi d. Actually you will get A5. For generalized what I wrote, I1 by 2 pi d AL cross AR. What is the AL? క్లియర్గా నోట్స్లో కూడా చెప్పానమ్మా. యూనిట్ వెక్టర్ along the direction of
current.
AR is the unit vector in the direction of field point. Okay na? AR is the unit vector in the direction. Here only important. Instead of A5 I generalized this formula. A5 place లో AL cross AR రాశాను. ఓకేనా? ఇది థర్డ్ యూనిట్ స్టార్టింగ్లోనే చెప్పాను. మీరు థర్డ్ యూనిట్ ప్రిపేర్ అయ్యేటప్పుడు చూడండి. మ్యాగ్నెటిక్ ఫీల్డ్ ఇంటెన్సిటీ డ్యూ టు ఇన్ఫైనైట్ కండక్టర్ చెప్పాను. అక్కడ ఈ ఫార్ములా చెప్పాను. ఓకేనా? నౌ అప్లై దిస్ ఫార్ములా ఫర్ దిస్ కండక్టర్ ఇయర్. ఇప్పుడు ఈ కండక్టర్కి అప్లై చేయండి. అప్లై చేస్తారా? Now tell me I want to calculate h1 here at a distance of d. h1 equal to, what is this current? I1 by 2 pi d. Distance is d. AL cross AR. ఇక్కడ చెప్పండి అమ్మా, what is the AL in this case? I1 by 2 pi d. What is AL? Direction of current కదా, positive AZ or negative AZ?
Positive AZ.
Very good. Positive AZ cross AR. What is the unit vector in the direction of field point? Field point ఇక్కడ ఉంది కదమ్మా, అంటే ఈ డైరెక్షన్ లో ఉంది. Field point direction. As it is an x-axis, what is the unit vector of x-axis?
AX.
AX. This is AX. So AZ cross AX. H1 equal to I1 by 2 pi d AZ cross AX. అర్థమైందా బాబు? రాకేష్, గణేష్?
Yes, sir.
Yes, sir.
Now now magnetic field intensity due to conductor 1 at a distance of d is given by h1 equal to I1 by 2 pi d AZ cross AX. Let us substitute this h1 in this equation. Then b1 equal to mu into h1 is I1 by 2 pi d AZ cross AX. Equation 2. Let us substitute this 2 in 1. This 2, this 1. Okay? Substitute 2 in 1, which implies F equal to I2 L2 cross B1, which is I2 L2 cross B1 is mu into I1 by 2 pi d AZ cross AX. AZ cross AX. So I2 L2. How to write L2 vector? What is L2 vector? Length of conductor 2. L2 vector equal to L2 vector equal to, in the conductor 2 also, how the current is flowing? In positive Z direction. Very good. L2 into AZ. So L2 into AZ cross mu I1 by 2 pi d AZ cross AX. What is the AZ cross AX?
AY.
Which is AY. Positive AY or negative AY?
Positive.
Positive AY. So I2 L2 again ఇక్కడ క్రాస్ ప్రొడక్ట్ చేస్తున్నాను. I2 L2 into mu into I1 by 2 pi d AZ cross AY. ఇక్కడ AZ cross AY. I2 L2 mu into I1 2 pi d AZ cross AY. What is the AZ cross AY?
AX.
Minus AX.
తెలుసు కదా, ఫస్ట్ ఏం వస్తుంది? AX వస్తుంది, తర్వాత AY వస్తుంది, తర్వాత AZ వస్తుంది. ఈ పాజిటివ్లో క్లాక్ వైజ్ అయితే AX AY AZ, AY AZ AX. బట్ ఇక్కడ ఏముంది? AZ AY. AZ AY equal to minus AX. So which is equal to finally mu into I1 I2 divided by I1, I2, L2 divided by 2 pi d in the direction of minus x. So this is connection line లో ఉండండి. What is this meaning of AX? ఇక్కడ మైనస్ AX అంటే ఏంటమ్మా? మనకి ఫైనల్గా ఫోర్స్ ఏమొచ్చింది? F12 ఈక్వల్ టు F12 ఈక్వల్ టు mu into I1 I2 L2 by 2 pi d minus AX. What the minus indicates? Force on which conductor, amma? Force on conductor 2 or conductor 1? What is F12? Force due to conductor 1 on conductor 2. What this minus AX indicates? The minus AX indicates conductor is trying to move. Chaptara, conductor is trying to move now. F12 equal to mu into I1 I2 L2 by 2 pi d minus AX. What this minus AX indicates? This conductor force on this conductor 2 and this is positive AX. Negative AX ఎలా ఉంటుంది? This is negative AX. That means this conductor is trying to move negative AX direction. ఈ direction లో మూవ్ అవుతుంది. అర్థమవుతుందమ్మా? What this unit vector shows? It shows the direction of force. Due to this force, this conductor is trying to move in this direction. అర్థమవుతుందా? ఈ కండక్టర్ ఇలా మూవ్ అవడానికి ట్రై చేస్తుంది. Between these two conductors, this conductor is trying to move in this direction. That is negative. What do you mean by force per unit length? F12 by L2 rastam. F12 by L2 means force per length equal to mu into I1 I2 by 2 pi d in the direction of minus AX. If they want to calculate magnitude, then you have to calculate mu into I1 I2 by 2 pi d. In some of the question, they want to calculate the force magnitude, force per length, mu I1 I2 by 2 pi d. Okay, force per unit length equal to this one. In terms of direction, this is the equation. Follow అవుతున్నారమ్మా?
Yes, sir.
Rakesh.
Yes, sir.
Okay. Now, this is one force. Next, what is the other force? Last one. Let me finish within 10 minutes it, so that we can finish all the forces. Last one interval. Force on which conductor? Force on conductor 1
1.
due to
B2.
Conductor 2, that is the force is known as F21. Okay, na? F21. మీరు కూలమ్స్ లాగా కూడా రాశారు కదా, there is a Q1 and Q2. Between these two charges there is a force. ఇక్కడ కూడా F12 రాశారు. What is the F12? Force due to charge 1 on charge 2. That is Q1 Q2 by 4 pi r square. 4 pi epsilon naught into r square. ఇక్కడ కూడా అంతేనమ్మా. Two conductors carrying current in same direction. Let us calculate the force. Now tell me the formula F21. చెప్తారు ఎవరన్నా? F21 equal to I1 L1 cross B2. ఓకేనా? డ్యూ టు కండక్టర్ అంటే ఈ కండక్టర్ నుంచి వచ్చే మ్యాగ్నెటిక్ ఫీల్డ్ అమ్మ, గుర్తుపెట్టుకోండి. డ్యూ టు కండక్టర్ 2 మీన్స్ ద మ్యాగ్నెటిక్ ఫీల్డ్ డ్యూ టు కండక్టర్ 2 ఆన్ కండక్టర్ 1 అంటే కరెంట్ ఎలిమెంట్ I1 L1 రాయాలి. I1 L1 is related to this conductor. B2 is related to conductor 2. So let us say again this is equation 4 అనుకోండి. ఇప్పుడు నాకు B2 కావాలమ్మా. B2 equal to mu into H2. What is the H2 here? Magnetic field intensity due to the conductor 2 at a distance of D1. Let me share again the diagram. ఇప్పుడు చెప్పాలి. What is this H2 at a distance of D? Now the field point is at this position. Field point ఇక్కడ ఉందమ్మా. The distance of this one. Due to this conductor 2, I am going to calculate H at this point. The distance is D. H2 equal to, formula ఇప్పుడే చెప్పాను కదా, current is I2 divided by 2 pi D AL cross AR. Now tell me here, I2 by 2 pi D. What is the AL for this conductor?
AZ.
AZ. Good. What is the AR for this conductor?
Minus AX.
As the field point at this position, ఈ కండక్టర్ నుంచి చూడండి అమ్మా. Take this conductor as reference. Take this conductor as reference and you have to look towards this field point. Field point ఇక్కడ ఉంది. అంటే ఫీల్డ్ పాయింట్ ఈ డైరెక్షన్లో ఉంది. ఈ డైరెక్షన్లో ఏ యూనిట్ వెక్టర్ ఉంటుంది? మైనస్ AX. So I have written as minus AX. I2 divided by 2 pi D into AZ cross minus AX. Got the point? ఇక్కడ మన డౌట్స్ ఉన్నాయా బాబు? ఇక్కడ కొంచెం డౌట్స్ వచ్చే ఛాన్సెస్ ఉంటాయి. If it is clear, then everything will be clear. Tarun, డౌట్స్ ఏమైనా ఉన్నాయా బాబు?
హలో సార్.
డౌట్ ఏమైనా ఉందా ఇక్కడ? డౌట్ ఉందా లేదా చెప్పండి.
No, sir.
డౌట్ ఉన్న వాళ్ళు అడగొచ్చమ్మా, ఎందుకంటే ఇది కొంచెం అర్థం కావడానికి టైం పడుతుంది. మైనస్ AX ఎలా రాసాను అనేది బేస్డ్ ఆన్ ద ఫీల్డ్ పాయింట్ యూ హ్యావ్ టు టేక్. ఓకే, సో ఇఫ్ యూ డోంట్ హ్యావ్ డౌట్ దెన్ ఐ విల్ ప్రొసీడ్. H2 equal to, what is the formula? I2 by 2 pi D. Distance is same. AZ cross minus ax. Now then b2 equal to mu into I2 by 2 pi d. Substitute this here, 2 pi d az cross minus ax. So this is equation 5. Now substitute this b2 in this 4. 5 in 4 implies what is the 5 in 4 implies? F21 equal to I1 L1 cross B2. What is this B2? B2 is mu into I2 divided by 2 pi d az cross minus ax. Okay. What is the az cross minus ax? Actually az cross ax ay kada,
minus ay.
ఏ వస్తుంది మైనస్ ఉంది కాబట్టి ఇక్కడ మైనస్ ay వస్తుంది. ఓకే, సో ఇట్ రిజల్ట్స్ మైనస్ ay విచ్ ఇంప్లైస్ I1. ఇక్కడ L1 కూడా రాయాలమ్మా. L1 వెక్టర్ ఈక్వల్ టు L1 ఇంటూ వాట్ ఈస్ ద డైరెక్షన్ ఆఫ్ ది కరెంట్?
AZ.
AZ. గుడ్. mu into I2 by 2 pi d minus ay, which implies finally mu into I1 I2 L1 by 2 pi d az cross ay. What is the az cross ay? Minus az cross ay actually minus ax, but already minus ఉంది కదమ్మా. Minus and minus into minus becomes plus. So az cross minus ay ఏమవుతుంది? ax అవుతుంది. ఓకే, సో which is mu into I1 I2 by 2 pi d into L1 ax. This is F12. Now come to the unit vector called ax, positive ax. Positive ax means how the conductor is moving in this one.
Away from the field point.
How this conductor is moving, Amma? Please respond.
Towards conductor 1.
Previously this conductor is moving in this direction. No? Now we are taking this conductor. Okay, na? How this conductor is moving? In the direction of ax and y, in this direction. So this conductor is trying to move in this direction. Now the conclusion is that this conductor is moving in this direction and this conductor is also moving in this direction. The conclusion is that if the current is flowing through the conductor in the same direction, I1 is in this direction and I2 also in this direction, the force between them is
Attractive.
very good, attractive force. Okay, na? Based on this, as this conductor is moving in the negative ax direction, as this conductor is moving in the positive ax direction, the force between these two conductors is force of attraction. Like the two charges plus q and 2 plus q1 and another one also plus q2. What is the type of the force between these two charges? Similar charges kama. Similar charge aithe force ela untundi?
Repulsive.
Repulsive. అదే ఆపోజిట్ చార్జెస్ అయితే
Attractive.
అట్రాక్టివ్. అది మనకు తెలిసిందే కూలమ్స్ లా నుంచి. అలానే ఇక్కడ కూడా if the two conductors are there, let me conclude it. Two conductors are there and it is carrying current I1 in this direction and this is current direction. So there is a force between these two conductors. Okay, then the force type of the force is attractive force. Next, if the current is flowing in opposite direction, then the force is repulsive. ఇప్పుడు హోంవర్క్ ఏంటంటే ఇప్పుడు మనం సేమ్ డైరెక్షన్లో క్యాలిక్యులేట్ చేసాం కదా. ఐఎమ్ గోయింగ్ టు గివ్ ఏ హోంవర్క్. సో ఇఫ్ యు ఆర్ ఏబుల్ టు డూ దిస్, then you can write these. You can write the answer for any question. Let me give a homework here. Z, X, Y, and this is one conductor. In this conductor, the current is flowing in this direction. And take another conductor. In this conductor, I2 is flowing in this direction. And length L1 and length L2. For this, calculate F12 and F21. మీకు క్యాలిక్యులేట్ చేస్తే ఏమొస్తుందంటే ఈ కండక్టర్ ఏమో ఇటు మూవ్ అవుతుంది, ఈ కండక్టర్ ఏమో ఇటు మూవ్ అవుతుంది. దెన్ యూ కెన్ సే దట్ ద ఫోర్స్ బిట్వీన్ దెమ్ ఈజ్ repulsive. Okay, so for this problem find F12 and F21. Okay na? తీసుకున్నారా మా హోంవర్క్ ప్రాబ్లం తీసుకున్నారా?
Yes, sir.
Okay, so let me share the let me conclude it. Finally, ఈ 4th యూనిట్లో ఇంకా ఏమన్నా డిస్కస్ చేయాల్సిన ఒకసారి నేను షేర్ చేస్తాను సిలబస్ కాపీ. సిలబస్ కాపీ కనిపిస్తుందా? షేర్ చేసిన సిలబస్ కాపీ.
Okay.
So far we have discussed about this 4th unit, that is forces in magnetic fields. ఈ పార్ట్ అంతా కంప్లీట్ అయిపోయిందమ్మా. ఫోర్సెస్ ఇన్ మ్యాగ్నెటిక్ ఫీల్డ్స్ అంతా అయిపోయింది. దట్ ఈస్ magnetic force, Lorentz force equation. What is the Lorentz force equation? F equal to Q into E plus Q into V cross B. Finally, Q equal to E plus V cross B. Next, that is Lorentz force equation completed. Force on current element in a magnetic field. What is that force on current element? F equal to I into L cross B. This is second force. Next force is force on a straight and long current carrying conductor in a magnetic field. At the same way. Next, force between two straight long parallel conductors. What is this force? చెప్తారా? ఇప్పుడు డెరైవ్ చేసాం. ఫోర్స్ ఫార్ములా F equal to mu into I1 I2 by 2 pi d. ఒకటేమో AX వస్తుంది. బట్ ప్రాబ్లంలో ఇస్తే మీకు ఓన్లీ మ్యాగ్నిట్యూడ్ క్యాలిక్యులేట్ చేయమంటాడమ్మా. mu into I1 I2 by 2 pi d. ఓకేనా? దట్ ఈస్ ద ఫోర్స్. ఇంటూ L2 కూడా ఉంటుంది, L కూడా ఉంటుంది. దట్ ఈస్ ద ఫోర్స్ బిట్వీన్ టూ straight long parallel conductors in first is same direction, current is flowing in same direction in both the conductors, and second one is opposite direction. ఏదైనా అడిగే ఛాన్సెస్ ఉంటాయి, సేమ్ డైరెక్షన్ ఆర్ ఆపోజిట్ డైరెక్షన్. సో ఇంతవరకు కంప్లీట్ చేసాం ఇప్పటివరకు. నెక్స్ట్ క్లాస్లో మ్యాగ్నెటిక్ డైపోల్, డైపోల్ మూమెంట్, టార్క్ ఇన్ ఏ మ్యాగ్నెటిక్ ఫీల్డ్, స్కేలార్ మ్యాగ్నెటిక్ పొటెన్షియల్ అండ్ వెక్టర్ మ్యాగ్నెటిక్ పొటెన్షియల్. సో ఈ స్కేలార్ మ్యాగ్నెటిక్ పొటెన్షియల్ అండ్ వెక్టర్ పొటెన్షియల్ ఉంది చూసారా, దీనికి వీడియో లెక్చర్స్ ఉందమ్మా, అది చూడండి. నెక్స్ట్ క్లాస్లో నేను ఏం చెప్తానంటే ఈ మ్యాగ్నెటిక్ డైపోల్ అండ్ డైపోల్ మూమెంట్ చెప్తాను, టార్క్ కూడా. ఎందుకంటే ఫస్ట్ క్వశ్చన్ మీకు ఏబి ఉండాలి కదా, 2 క్వశ్చన్స్ వస్తాయి. వన్ క్వశ్చన్ విల్ కమ్ ఫ్రమ్ దీస్ ఫోర్సెస్, సెకండ్ క్వశ్చన్ విల్ కమ్ ఫ్రమ్ డైపోల్, డైపోల్ మూమెంట్ అండ్ టార్క్, లేకపోతే ఈ స్కేలార్ మ్యాగ్నెటిక్ పొటెన్షియల్ కూడా ఇవ్వచ్చు. సో ఇన్ నెక్స్ట్ క్లాస్ I will teach